Good morning, class. I'm going on to section 6.3 of the chapter, and it is called Sine Rule. Okay, Sine Rule. Now let me repeat how we label a triangle again. This is angle A, angle B, angle C. The side opposite big A is little a, the side opposite big B is little b, and the side opposite big C is little c here. Now, what does sine rule says? Okay, it means A over sine A is equals to B over sine B is also equals to C over sine C. Now, you can flip it all up. That means sine A over A is equals to sine B over B is equals to sine C over C. Also can. Alright? Now, I want to take note of two things. Number one, when it is a right-angled triangle, you don't use sine rule. Use the Pythagoras theorem or Tuakaso to solve the question. Do not use the sine rule. Now, it is not wrong, but it is a waste of time because it is very tedious. Okay, you will realize that sine 90 degrees is actually 1. Okay, sine 90 degrees is actually 1. And for right-angled triangle, there is no need for us to use sine rule or even cosine rule in the next session. Okay, now next I want to take note that for a triangle, the longest side is always opposite the biggest angle, and likewise, if it's a small angle, the smallest angle, the shortest side must be opposite the smallest angle. This is something that you need to take note of. Alright, now I am going on to example 6 of your textbook. Let's take a look at example 6 on page 189. I'm going to show you how the sine rule is being applied to example 6. Okay, how the sine rule is being applied to example 6. Now, first part, they ask you to find angle C. This angle C actually no need anything, you just need angle sum of triangle, you will get 66.9 degrees. Okay, part 2 asks you to find the length of BC. Now, I want to take a look. BC is here and it's opposite this angle. Okay, so BC over sine 67.6 is equals to 7.6 over sine 66.9. Okay, that means we always take like that, opposite to apply the sine rule. So BC, you bring this over, you will get this final answer, 7.64. Now, likewise, let's take a look at how do we find the length of AC. Now, class, AC is here. And you know that AC is opposite this one. So it's AC over sine 45.5 degrees is equals to 7.6 over sine 66.9 degrees. You do the manipulation, you'll be able to get the answer. Now, always try to use the answer that's given in the question. Sorry, the information that's given in the question. Now, some people will say, can I use BC? That is this answer with 67.6 is also okay. It doesn't matter. But if you take a look, this one you found it out. 66.9 is easier to find than this one. So it's more likely that you make mistake here than here. So we always try to use the information that we feel that is more correct. Okay, that is, we always use the information that is given in the question itself to avoid mistakes. Okay, this is your example 6. Now, next, I'm going on to example 7. Example 7. Okay, now let us take a look at example 7. What does it say? Now, it says to find angle C. Now, this is angle C. This, you're supposed to find this angle, huh? Angle C over here. Okay, sine of this angle over 7.5 will be sine 50 over this. Now, take note, if you put angle here, all the angles are on top and the lengths are below. If you put the length on top, then all the length must be on top and all the angles are below. Okay, it must match. Alright, so sine angle C is this, then I find it out to 5 truncate. Okay, now remember I said sine positive, there are two angles available. One acute and one obtuse. So the basic angle is this. So angle C is either equals to 37.212 or 180 minus 37.212. Now why is it so? Because this basic angle here is 37.212 and this basic angle here is also 37.212. Now sine is positive, so it lies either in the first or the second quadrant. So the angle is either acute or obtuse. Okay, acute or obtuse. Now, why is it that I reject this? Why is it that I reject this? I want you to take a look at the picture here. Now, 9.5 is opposite 50. Okay, 9.5 is opposite 50. 7.5 is opposite this angle. Now, can you see that 7.5 is less than 9.5? Therefore, this angle must be less than 50. Because I told you just now, the biggest angle will be opposite the longest side. So this is a longer side, this must be a bigger angle. So this one must be a smaller angle than 50 because this is only 7.5. Okay, so this is rejected. Therefore, angle C is just one answer, 37.2 degrees. Okay, 37.2 degrees. Alright, now you can also think about it when you look at it. When you look at this particular question, you must always ask yourself, before you start anything, is this angle bigger or smaller than this according to the sides? That it will tell you which one to take and which one to reject. Okay, now next we are going on to the second part, and it's called finding angle A. Now when we find angle A, we must take 180 minus 50 minus 37.212, and you give you 92.788 degrees. Now remember, for angles in degrees, we must always give it to one decimal place final answer, and for working we always give it to 3 decimal place truncate. So angle A will be 92.8 degrees. 92.8 degrees. Okay, now part C, they say to find the length of BC. Now this is simple. BC over sine of the opposite angle, 9.5 over sine of the opposite angle, that's 50, you will get the final answer, 12.4. Now this is what I mean by what I said just now. Can you see in part 1, I put sine on top, therefore the length is below. Okay, for part 3, I put the length on top, therefore the sine is below. Any way will do, but you must make sure it corresponds. You cannot swap the order around. Okay, so this is your example 7. Okay, now example 8 is a tedious question because it talks about something that is very unique to sine rule, and this is called the ambiguous case. Now what do you mean by ambiguous case? Ambiguous case means that there are two possible sets of answers. Okay, now I'm going to show you now why are there two possible sets of answers. Okay, now if you look at this triangle here, first they ask you to find angle ACB. Okay, now you look at this. This is 55, this is 14.3. This is 16.3, and this is opposite the unknown angle that we are supposed to find. Now, because this is bigger than this angle will be bigger than 55 degrees. Okay, I repeat, this angle will be bigger than 55 degrees. So I'm going to use the sine rule here. I get sine as this, basic angle as this. This is as per normal, like what we do in front. And I will get two angles, 69.020 and 110.98. Okay, so I have two angles. Now, because this length is bigger than this length, this angle is bigger than 55. Now, can you see that both angles, both solutions here are all bigger than 55? And I cannot reject anything because I do not know what's the answer yet. So there are two cases here. Okay, there are two cases here. Now, case A, when angle ACB is 69.020, angle BAC will be this. You minus 69.020 and 55, you get this answer. So for angle ACB 69, you will get angle BAC as 56. This is one set of answer. Okay, now then remember we have this particular answer also. So case B will be when angle ACB is 110.98 degrees. What is the answer? Okay, so you get 180 minus this, you get this. So you get another set of answers. Okay, both answers are possible, so therefore there are two cases. Now can you see that if there are two answers to angle BAC, alright, angle BAC, for the next part, to find the length of BC, there will also be two answers, because there are two possible answers for angle C itself. Okay, so what are we supposed to do? We are still going to do case A and case B. Alright, for case A, where the angle here is 69.2020, we will apply sine rule. BC is this length. Okay, we apply sine rule and BC is this length. Okay, so the first set of answer will be this. With angle ACB 69, angle BAC 56, and BC 14.5 cm. Now, just now we have two answers for angle C, 69.020 and 110.98. For case B, this angle here will be 110.98. Okay, now, so we will take BC over sine 14.02 equals to 14.3 over sine 55 degrees. Okay, so we do the manipulation, you'll get BC as 4.23 cm. So this is the second set of answers, whereby angle ACB is 111.0, angle BAC is 14.0, and BC is 4.23 cm. There are two possible sets of solutions in this particular case. Alright, now if you need to replay this example to understand it better, please feel free to do so. But I am going to summarize when there will be one answer and when there will be two answers for you. This is a summary for you. Alright, now to sum up, if you are given a triangle, can you see that these two are known? That means I know 52 and I know 4.9. You are supposed to find this angle C here. Now can you see that this 4.5 is less than 4.9? Now when this side is less than this angle only has one value. Okay, I repeat, this set of values are given 52 degrees and 4.9. Now this is 4.5, which is less than 4.9. So in order to find this angle will be having only one value because this is less than this. Okay, now when will it have two values? Let's take a look at another triangle. Okay, now can you see that this pair of values are given to you, 52 and 4. Now you're supposed to find angle C, but can you see that this length here, 4.5, is more than 4? When this length is more than this angle C will have two values. Okay, this angle C will have two values. So this is a summary for the ambiguous case. Alright, okay, now I'm now going to go through your homework exercises so that you can understand. Please take out your foolscap paper so that I can go through the homework answer. Okay, now for question number 3, I must teach you again how to label the sides. Now they ask you to find the length of the longest side. Now if This is 75, this is 60, this is 45. You will see that the longest side is actually QR because it's opposite the biggest angle. Okay, now the question did not give you a diagram, and they say little q is 14 cm. Now you must know that little q must be opposite big Q. Okay, so we apply sine rule here and we will get QR as 15.6 cm. Okay, QR as 15.6 cm. This is question number 3. Okay, now for question number 4, sorry, not number 4, number 6. Okay, now they did not give you a triangle, so it's best to sketch a triangle. The triangle need not be accurate, it's just a visual help for you to see the triangle. Now they want to find angle BAC, so you put this over this is equals to this over this, you manipulate, you get this answer. Now because sine is positive, there are two answers, 39.6 and 140.4. Now this one is rejected. Okay, this one is rejected. Why? Okay, why is 140.4 rejected? Okay, now you look, this is 11.6 and the angle is 91. This is 7.4. Therefore, this angle here must be less than 91. Okay, so angle BAC must be less than 91, so we will take 39.6. Okay, no problem. Now, if that's another way to check which one is rejected. Now, if this angle is 140.4, can you see that 140.4 plus 91 already exceeded 180 degrees? An angle sum of triangle is 180 degrees. So this cannot be accepted as well. That's why it's being rejected. So another way to check whether you want to reject an answer is to add up. If the answer for the angle sum of triangle exceeds 180 degrees, that means that answer must be rejected. Okay, I repeat, if angle A is 140.4, if I plus 91, okay, now let me just give you the answer. You will get 231.4, which already exceeded 180, and you have not even added this angle yet. Okay, so please be, this is another way to check your answer. Okay, now part 2, they ask for angle ACB, so you just take angle sum of triangle, you'll be able to get the answer straight away. And for part 3, we just apply sine rule to get the length of AB. Okay, for part 3, we just apply sine rule to get the length of AB. Alright, that will conclude your question number 6. Okay, I am moving on to question number 7. Now for question number 7, you are supposed to find the length of AB. Now this is a right angled triangle, so there's no need to use sine rule. I just use Tuakaso will do. I will get the answer as 12.5 meters using sine. Okay, the ratio sine. Now next, part 2, find angle NBD, the green angle. This is also a right angled triangle, so I just use cosine. I will get this answer. And when we want to find the length of CD, we just use the sine rule to get the answer. Okay, part 3, we just use sine rule to get the answer. And how do I get this angle here? I use angle sum of triangle. Okay, now I am moving on to question number 12. Okay, let's take a look at question number 12. Okay, alright, for part 1, you are supposed to find QR. QR, this is a right angled triangle, so I just use sine. I can get the answer as 2.64 cm. Okay, now part 2, we are also dealing with a right angled triangle. Okay, and I will get the answer as 55.8 using cosine. Now, let me just reiterate. When you have a right angled triangle, you either use sine, cosine, tangent or Pythagoras theorem. There is no need for you to use sine rule. But if you use sine rule, you are also not wrong, just that it's very tedious. Okay, now for part 3, you're supposed to find angle PST. Angle PST. Now, where is angle PST? It's the red angle over here. Okay, angle PST is the red angle over here. This one. Now, we will find that sine is positive. When sine is positive, there are two possible angles, one acute and one obtuse. Okay, so it's this one and this one. Now, how do we know whether we reject it or not? Okay, we can do it in two ways. Okay, let's take a look. Now, this is 3.2 and this is 64.2. This is 2.7. Obviously, this red angle will be less than 64.2, which will be 49.4. Another way to check, if this angle is 130.6, if I add up to this, it already exceeded 180, so it cannot be a triangle. So this one is rejected. Okay, you can use either reason to reject it. Okay, alright, so that will conclude your question number 12. Okay, now I'm moving on to the last question, and that is question number 15. And question number 15 is the one that is the ambiguous case. Okay, now I'm going to present you in a concise manner, not in a nice manner. Okay, in a concise manner. Okay, can you take a look at this particular question? Okay, now question 15 says to find angle ABC, ACB, and the length of AB. Now I'm going to show you the answer. First, I want to find angle ABC. Okay, now I want to take a look here. This is opposite. Okay, this one is opposite, and you want to find this angle. Can you see that this is longer than this? Therefore, this one will have two answers. This angle here will have two answers, just like what I've said in the summary for the ambiguous case. Okay, so first I apply sine rule. I'll get sine angle ABC as this, basic angle as this. I will have two solutions. Okay, I'll have two solutions. This will be my case number 1. This will be my case number 2. Okay, case 1 is when angle ABC is 68.883. Case 2 is when angle ABC is 111.117 degrees. Okay, let's take a look at case 1 first. Okay, I will just concentrate on case 1 first. Okay, case 1, if angle ABC is this, I'll find angle ACB as this. Okay, then I will apply sine rule to find AB. I'll get 13.204 cm. So if I take this set of numbers, I will get angle ABC as this, angle ACB as this, and AB as this answer. But don't forget, answers to angles are rounded off to 1 decimal place, and length is to 3 significant figure. This is the first set of answer for case 1. Okay, now there is another case called case 2. Now what is case 2? Case 2 is when angle ABC is 111.117. I will use angle sum of triangle to get angle ACB. I will use sine rule, and I will find AB as 3.12. So for this second case, I will get this set of answers over here. Now both sets of answers are acceptable because this is an ambiguous case whereby there are two sets of solutions. Okay, this will further reinforce the example 8 which we have. Okay, which we have. Now before I end, I just want to reiterate one point, and that is the summary for ambiguous case. Okay, summary for ambiguous case. I'm going to repeat this one more time. Okay, now if the given angle and side is like that, and this is a length that is smaller than this angle here will only have one value. Okay, now if this is the given angle and side, and this is more than this angle here will have two values. So this is what we mean by the ambiguous case. Alright, class, you can replay any parts you want so that you can be clearer, and this will conclude the part for sine rule. The next section that I'll be going to will be the cosine rule, and that will be in the next video. Thank you very much.